So now that we've gone through the official formula for the chain rule, there are, as for the other differentiation rules that we know, there's always a quicker and easier way to do it. And that's what we're going to go through now. And yeah, just sort of build our efficiency with the builds of these more complex functions. So we've got these two rules here, and they're both pretty kind of similar. The first one's kind of a simplified version of the second one. So this first rule is saying that if you've got a linear function, and then you got something that's being powered, or that's taken to the power of something, then what we do is you take the coefficient or whatever the x value was. So we just take the coefficient of whatever the x value was, which is a. You put that outside and you multiply it by the power, which is n. Then you leave the actual linear function by itself in a bracket and just subtract the power by 1. Okay, so to give a simple example of that, say you have 2x plus 3 to the power of 5. So the derivative of that would be the coefficient of x is 2 and the power is 5. So we'll do 5 times 2 at the front. Then the actual linear function inside the bracket stays the same and the power reduces by 1. So that becomes 4. So this becomes, obviously, 5 times 2 is 10. So just 10. And then 2x plus 3 to the power of 4. Okay? And the second formula here, it's basically an extension of that one, but it sort of applies to all functions. So it doesn't matter inside if you have a linear function, a quadratic function, a cubic function, a square root, whatever it is. What we have to do is you bring the power to the front and we leave the function as it is and then reduce the power by 1. And then we multiply that by the derivative of whatever is the actual function. The singling the chain will, how we learn in the rule, we separate that actual function and we say let u equal to that, and then we derive that, multiply together. That's basically what we're doing here. We're finding that function inside, we're deriving that, and we're multiplying that by these things here, and that gets you the same thing. Okay? So now we're going to use these rules to answer these questions. And just to show you guys how we can do it without having to go through it using the whole dy over du, dy over du and du over dx without having to go through all that stuff. Okay? So let's go through the first one here. So we've got y is equal to 1 over to the power of, y is equal to 1 over 5x minus 6. So first thing I'm going to do is I'm just going to put this in index form. So y is equal to 5x minus 6 to the power of minus 1. Okay, now to derive this, again, we've got a linear function inside, as you can see, because there's no power of x, so we can use this first rule here. Okay, so over here, dy over dx is going to equal to, so the coefficient of x here is 5, and the power is -1. So 1 to 5 times -1. And then the actual linear equations inside stays the same. And we reduce the power by 1. So -1 minus 1 becomes a -2. Okay. Now 5 times -1 is just -5. And then to get rid of this -2 in the power, we're just going to bring that down to the bottom again. So that just becomes -5 over 5x minus 6 squared. And that's your dy over dx. Okay, so as you can see, a lot easier, a lot simpler. This is the more efficient way of doing it. Once you're confident with the rule, then we can start using these quicker sort of shortcuts. But the rule itself is still very important to know. So just make sure we do have a good understanding of that, because then we'll be able to do these properly as well. The next question, y is equal to square root 2x of 3, again, in index form. That is just 2x plus 3 to the power of half. And again, we can use the same first rule here, because we've got a linear function inside, right? There's no power inside this function here. So dy over dx is the coefficient of x here is 2 times the power, which is half, and then keep that equation the same and subtract the power by 1. So half minus 1 becomes negative half. And then 2 times half is just 1, so this becomes 2x plus 3 to the power of negative half. And to get rid of the negative here, we'll just bring that down in the denominator. So that becomes 1 over square root 2x plus 3. Okay. Again, very simple. In just about 4 lines, we've answered that. Okay. Moving on to the next question. We've got C. So now this one's a bit different because there's not a linear equation, but we've got an actual, we've got a quadratic function inside. So we've got f of x now is equal to 2x plus x squared to the power of 5. So now we're going to see how we use the second rule here. Okay. So first thing it requires us to do is have the power at the front. Okay, so let's do that. So we're going to write f dash or x, and we'll bring the power to the front. And then we keep the function the same. So we'll keep that the same, 2x plus x squared. And then the power now becomes minus 1. So 5 minus 1 becomes 4. And then we have to times that by the derivative of this actual inside here. So the derivative of that is the derivative of 2x is 2, and the derivative of x squared is 2x. So that's your derivative there. 5 times 2x plus x squared to the power of 4 times 2 plus 2x. Right? And you can see it's a very similar thing. What we're doing is in the chain rule, what you would do is we would say that this equal u, and we would derive this, which would give us that, and then we would say fx is equal to u to the power of 5, which would give us this part. So this is our basically this is our dy over du, and this is our du over dx. Right? So it's very, very, very similar sort of thing that's going on here. And now for the last question. Let's have a look here. So we've got y is equal to negative 6. And again, I'm just going to straight away bring everything to the top because we don't like fractions when we're deriving until we learn the quotient rule, which we will learn in a bit. Okay, but that's our equation now without any fractions. And again, we can use the same rule as here, right? This is the same thing. The only difference is we've just got a constant at the front, but that really does not make any difference at all. So that's how it looks. So we just leave that constant as it is, right? So negative 6. Then we've got what we have. So you have the coefficient of x, which is just 1. We times that by 1, and then we times that by the power, right, which is negative 3. And then we leave the actual expression in the brackets by itself, and we just subtract the power by 1, so that becomes negative 4. So negative 6 times 1 times negative 3 is just 18, and then we can bring this back down to the bottom, and that becomes x to the power of 3, so x plus 3 to the power of 4. Okay? So again, in just 3 lines, we've answered all of that. Right, so it just becomes a lot easier to do these sorts of questions when we've got these quicker rules. But you should know the rules, so we understand how we base it off that, and how this is just sort of a simplification of that rule that with the actual chain rule that we've read before.